let us continue further, sir. I believe that whatever the basics we have studied in quadrilaterals, rhombus, triangles, and then square, rectangle, area, perimeter, all these parameters, I believe that it is very, very clear for you people. Now, before I continue further, I am sure that, okay, let me tell you what is that we are going to discuss in detail today. This is what we are going to discuss in detail today. Basic questions based on area of a triangle. We know the area of triangle. We have seen several types of triangles like equilateral triangle, isosceles triangle, scalene triangle, probably right angle triangle, and other varieties. However, the formulas, how the formulas will look like, how it can be derived, all those things we have already seen it. So we will solve some basic questions based on this area of triangles in mensuration two-dimensional figure in this particular class. Now, before we move on to our problems, let me revise it one little time with a very, very brief introduction, whatever I have discussed earlier on area of triangle. So we will see all the varieties what we have discussed it till now. Now suppose there is a triangle like this, right? There is a triangle. This triangle will have the base. This triangle will have the height, right? A triangle will have the base and also it will have the height. Now suppose if I name this triangle as triangle ABC, opposite side of angle A, I will represent it as small letter A. Opposite side of angle B, I will represent it as small letter B. Similarly, opposite side of angle C, I will represent it as small letter C. This is something which I have already told you. Now, if I draw a perpendicular, this becomes 90 degrees. This will be A by 2 and A by 2. Now, I am sure that I told you how to derive the area of triangle. Area of triangle is nothing but half into base into height. This is the generic notation to find the area of triangle. Area of triangle is given by the notation half into base into height. How it is half into base into height, all those things, let us not worry about it right now, sir. So in this case, the base is A and the height is H. So in this given figure, area of triangle is half into A into H. Now, I also told you another notation to find the area of triangle. It is by using a Heron's formula. What is that Heron's formula or Heron's notation? I told you that area of triangle is given by square root of S into S minus A into S minus B into S minus C, where A, B, C are the three sides of the triangle and S is nothing but take the perimeter of the triangle A plus B plus C and divide it by 2. S is nothing but the semi-perimeter, right? This also is another way of expressing or looking into a area of a triangle. Suppose I can also express the area of triangle in another way. Suppose I told you this very clearly in my explanation part. Area of an isosceles triangle. Suppose there is an isosceles triangle. What is the meaning of an isosceles triangle? Isosceles triangle means two sides should be same. The area of that isosceles triangle, we derive it saying as it is B by 4 into square root of 4a square minus b square. B by 4 into square root of 4a square minus b square, where two sides are equal. Two sides, in this case I am taking it as A and another non-equal side is represented as B in this case, right? This is the area of an isosceles triangle. This also explained you people. Now, another way of looking into an area of a triangle. Suppose if the area of a triangle, what I am finding here, let it be an equilateral triangle. What is the meaning of equilateral triangle? In an isosceles triangle, two sides were equal. One of them was an unequal side. Make that unequal side also as an equal side, right? Make that unequal side equal to that particular both equal sides. That means make B is equal to A in my example. In that case, area of an equilateral triangle is 3 by 4 into side square, where side I am taking it as A in that particular example. 3 by 4 into side square. And there is another type of triangle which I discussed, area of a scalene triangle. Scalene triangle is nothing but all the three sides are unequal. none of the sides are equal in a scaling triangle, and area of such kind of triangle is half into base into height. And if it is a right angle triangle, anyway I told you very clearly that if it is not a right angle triangle, also to find the height, we will drop that height, when we drop that height it becomes 90 degrees and it becomes two right angle triangles. That means if the area of scaling triangle is half into base into height, area of right angle triangle can also be found out as a half into base into height. I hope you are understanding the difference. There is one type of triangle which I did not explain you. It is not a triangle type basically. There is one notation of area which I actually did not explain you before. Let me explain you that part also right now itself. Now, same logic sir, very easy. If I take this triangle as a triangle ABC, opposite to angle A, I will take it as a side A. Opposite to angle B, I will take it as a side B, small letter B. Opposite to angle C, I will take it as a side C, small letter C. Now, if the sides are known to you, you can use that Heron's formula. Area of triangle is square root of s into s minus a into s minus b into s minus c, where s also can be found out very easily as perimeter divided by 2, that is nothing but semi perimeter. Now in this case, suppose for example, if the sides are known to you and if the angles are also known to you, then what I can do is area of triangle can also be represented as it is half into BC sin A, this is equal to half into CA sin B, and this is also equal to half into AB sin C. Sir, how are you actually finding it? We will find it actually by using sine rule. What is that sine rule? Sine rule also probably you might have studied in your trigonometry or some other topics also. It is A divided by sine A will be equal to B divided by sine B will be equal to C divided by sine C. From here you can derive this area of triangle, but I will not be interested in telling you the entire derivation, which is not required for us. In simple, if I want to remember, if I am taking sine of angle A, what is the side which is opposite to angle A? Opposite to angle A is small letter A. Please forget that small letter A and write the other two sides BC along with this half. Similarly, if I take the sine of angle B, forget that opposite side small letter B and take the other two sides AC along with this half multiplied. Similarly, if I take the angle as sine C means opposite side is small letter c, forget that small letter c and take the other two sides AB along with half multiplied to it. Area of triangle can also be found out in this easy way. I hope the idea is very clear for you people, sir. Right? Based on these areas, whatever we have learnt till now, let us solve some questions on area of a triangle. I hope the idea is clear. I believe that you are getting the flow of this class. We are still in basic level question, probably little intermediate level questions also we will discuss as of now, but not too much high level questions at this present moment. But do not worry about it. We will see all the varieties of questions are being covered, and we will see how beautifully we can solve some of the mensuration questions in the most easiest way possible. Now see here, sir. Now listen to this carefully. Let us solve some questions. Let us start with a very basic question. Find the area of equilateral triangle with side 6 centimeters. Now see here. They are very clearly mentioning that whatever the triangle ABC which I am drawing right now, this triangle ABC is, it's an equilateral triangle. And side is also given in the question as 6 centimeters. So all these three values are 6 each. AB is equal to 6, BC is equal to 6, CA is also equal to 6. Now we already know the area of an equilateral triangle. What is the area of an equilateral triangle? Area of an equilateral triangle is root 3 by 4 into a square. A is nothing but side in this square, side in this case. So it is root 3 by 4 into a value is 6. It is 6 square. 6 square is 36. If I simplify, this is 4 into 1, 4 into 9. So can I say that area of this equilateral triangle is 9 root 3? Yes. Answer for this question is very easy question. Answer is 9 root 3. But what I actually want to teach you is, sir, you said that you wrote some 4 to 5 notations or 5 to 6 notation to find the area of triangle. All these are area of triangle itself. Forget about whether it is differentiated as equilateral or isosceles or scalene or right angled or whatever it is. But ultimately at the end of the day, all these are area of a triangle. That is one thing which I am very interested about. I am interested about that word called as a triangle, that geometrical figure called as triangle. Everything is representing the area of a triangle. Can I use all the other notations which you have explained before the start of that problem and get the same area? Yes. The question is very clearly stating as the area of an equilateral triangle. Definitely you will use this notation because you know it directly. But can I use the other notations, other 4 or 5 notations which you explained, and can I arrive at the same answer as 9 root 3? Can you please help me in getting that? Definitely you can get it, sir. Definitely there is no doubt that you will get a different area. You will definitely not get a different area. You will get the same area. Now see here. This is by using directly the notation of an equilateral triangle. Suppose for example, we also know that area of triangle is half into base into height, right? Area of triangle is half into base into height. Base is known as 6 centimeters. What is the height, right? What is the height of it? Now height is give height of an equilateral triangle, that also we know it already. It is root 3 by 2 into side. It is root 3 by 2 into 6. This is nothing but 3 root 3. That means height is nothing but 3 root 3. Sir, should we remember this formula, height root 3 by 2 into side? Definitely no. I explained you how you got this root 3 by 2 into side when I took the proof of it in my explanation of formulas. There you took 6 as 3 and 3 and you applied Pythagoras theorem. You can use that logic also, sir. You don't need to by heart. But I just used it because we believe that we should know it, right? Now see here, can I say that if I use this notation, for example, so area is half into base is nothing but 6, height is nothing but 3 root 3, so it is 2 into 1, 2 into 3, 3 into 3 is 9. So ultimately, eventually you got the same area here also what you got in the first case as 9 root 3. I hope you are understanding the logic. That is okay, sir. You used half into base into height, you got the same answer. Wow, it is excellent. You used directly the area of an equilateral triangle, you got the same answer. That is also very good. But can I use the area of an isosceles triangle and can I arrive at the same answer? Now see here, sir. What is the meaning of an isosceles triangle? Isosceles triangle means suppose this side is A. This side will also be A. Let me take this side as 6. This side also has 6. Now, this should be a different value, right? But the question says it is an equilateral triangle. I will call it by a different variable. May not be different value. I will call it by a different variable for my explanation purpose. But I will put the same value because the main question says it's an equilateral triangle. Now, if I apply this in my area of an isosceles triangle, what is the area of an isosceles triangle? It is b by 4 into square root of 4a square minus b square. If I substitute, b value is also 6. It is 6 by 4 into square root of 4 into 6 square minus b value is again 6 square. I hope you are understanding the logic. Simplifying further, 3 by 4, 3 by 2 it becomes, this is 3 by 2 into 6 square if I take common factor. Square root of 6 square is outside taken as 6 and square root of 4 minus 1 it becomes, it is root 3. So it is 2 into 1, 2 into 3. 3 into 3 is 9 root 3. Even if you take the area of an equilateral triangle or if you take the area of an isosceles triangle, you will still get the same answer because area of an isosceles triangle means A and B are different. But according to the main question, it's an equilateral. So it should be named as the same value 6 for A and B. So it will ultimately give you the same answer 9 root 3. Sir, okay. This is area of equilateral you applied, isosceles you applied scale in. Yes, half into base into height also you applied. You told another two notations. Those two notations are area of a triangle by using Heron's formula. Can you please explain and prove that? We will get the same answer in that case also. Why not? Definitely you will get the same answer. Area of triangle by Heron's formula is square root of s into s minus a into s minus b into s minus c, where s is equal to semi perimeter a plus b plus c by 2. Can I say that all the three values are same 6 in this question? A, B, C values are same. 6 plus 6 plus 6, 18 by 2. S value is 9. Substituting here. So this is 9 into S minus A is 6. 9 minus 6 is 3. 9 minus 6 is 3. 9 minus 6 again is 3. So it is. Can I also say 9 into 9 is 81. Square root of 81 is taken outside as 9. Another 3 is left there itself within the square root. You got the area as 9 root 3 once again. Whether you take Heron's formula or an equilateral triangle formula or an isosceles triangle, it really does not make any difference. I hope you are able to understand this beautiful logic, sir. This is one of the reasons you should keep studying all these things in the most easiest way possible. Sir, this is also okay. But you told another beautiful notation which is derived from sine rule. Can I use it? Why not again? Definitely yes. Suppose if this is the triangle ABC, it is given in the question that all the three sides are equal. If all the three sides are equal, definitely all the three angles also will be equal. Sum of three angles in a triangle is 180. So each angle should be 60 degrees. That means if I take this as side A, this as side B, and this as side C. Now area of triangle is also given by half into A into B. If I take A and B, angles should be sine C, right? Angle should be sine C. But can I say that C is also 60 degrees only? You take any angle, all the angles are 60 in an equilateral triangle. So it is half into A value is 6, B value is 6, sine 60 value. Sine 60 value is root 3 by 2. First of all, if I simplify, this becomes 3 times. So it is root 3 by 2 into 3 into 6. Again 2 into 3. 3 into 3 is 9. Ultimately, you will get the same answer. In this case also saying that it is 9 root 3. That means, can I conclude so beautifully like this, sir? Whether it is an equilateral triangle or an isosceles triangle or a scaling triangle, or by using Heron's formula or by using that sine rule formula, you will never get a different area as long as your calculations are 100% right. You take any kind of a triangle. Question says it's an equilateral triangle, but still I can use the notation of an isosceles triangle and get the same answer. Question says it's an equilateral triangle, but still I can get the same notation. I can use the same notation of whatever I will use it for half into base into height for a scaling kind of a triangle and ultimately get the same answer. If the question says equilateral, even though the question says equilateral triangle, I can still get the same answers by using Heron's formula or by using the formula which is derived from sine rule. I hope the idea is very clear. Irrespective of different notations for area, ultimately you can get the same answer as long as your calculations do not have any mistake. I hope the idea is clear for you people, sir. See this question, sir. Your question is, find the area of a triangle. There is a triangle which is given here. Find the area of a triangle having two sides, 6 centimeter and 7 centimeter. One of the side I am calling it as A, 6 centimeter. Another side I am calling it as B, which is 7 centimeter. And the included angle being 30 degrees. With these two sides, the angle which is included included angle is 30 degrees. Find the area of that kind of triangle. Now see here, the area of this kind of triangles can be easily found. That is the reason I discussed varieties of notations for area, sir. Very easily you can find it right now, because you know one of the angle, and the opposite side of that angle is unknown. You don't even have to know that opposite side, because we need to forget that opposite side. Other two sides should be known. Yes, so this can be written as area of triangle is half into AB into, if I write AB, I should take the sign of other angle C, whichever the letter which I did not use it, I should take it. So it is sin C. Substitute, get the answer. Simple. Still we are in basic questions. I am repeating that statement so many times. Please have patience. A value is 6, B value is 7, sin 30 value is 1 by 2. So ultimately this becomes 2 into 1, 2 into 3. So it is 21 by 2, or it is 10.5 square centimeters. Area of triangle is 10.5 square centimeters. Easy questions to solve. Now see here. Let us solve the next question. Please see this question, sir. Very, very good question. Let us understand this question and then solve it in the most easiest way possible. Now, find the ratio of area of triangle ABC and triangle ADE. That means, let us write what is required. Area of triangle ABC and area of triangle ADE. This ratio is what I require. I need to find the ratio. If AB is equal to 6 centimeter, okay, diagram is given like this. AB value is given in the question as 6 centimeters. AC is 4 centimeters. AC from here to here, from here to here, this value is given in the question as 4 centimeters. AD is 6 centimeters. From A to D totally it is 6. That means the CD value can be taken as another 2, because AC is 4. 4 plus 2 is only 6. AE is 6 centimeters. AE value is also given in the question as 6 centimeters. I hope this is clear. AC value is given as 4. Here also I have written. Here also I have written the same AC value. AD value is given as 6. So CD becomes 2. And this entire value of AB is 6. AE is also 6. Now see here, sir. We know the property that why, okay, first of all, what is that property? The angle in a straight line is 90 degrees. Angle in a straight line is 180 degrees, right? Angle in a straight line is 180 degrees. Sir, why are we using that notation right now? Now see here, sir. If I don't know this particular angle, I will take this angle as a theta. This value is not actually given in the question. It is not even given as a theta in the question. This is something which I have drawn it and pasted it so that I will not waste time while taking the actual problems. That is the reason it is already printed there, right? This angle, if I take it as theta, this another angle, so that the total angle is 180. Total angle is 180. This angle is theta. The remaining angle becomes 180 minus theta, right? The remaining angle becomes out of 180. Theta is that left side angle, so right side angle will be 180 minus theta. Now, why are you using it, sir? It should immediately strike your mind saying that what we are discussing in this question is ratio. Ratio is nothing but one value divided by the other value, right? Ratio is nothing but fraction in another way, right? That means, can I say that I know that from the previous question, I can use this kind of notations of sine of some angle. Using that sine rule property, I can use that sine of that angle kind of notation to find the area. Can I say that if I use sine for this angle theta, I will get it as sine theta. If I use sine of the angle for this particular angle 180 minus theta, I will get it as sine of 180 minus theta. But from allied angles, what we have beautifully understood in trigonometry topic is, from allied angles, sine theta and sine of 180 minus theta both are absolutely same. Sine theta and sine of 180 minus theta both are absolutely same in allied angles, what we have studied in our trigonometry topic. That means when I take the fraction numerator, if I get sine theta, Denominator I will get sine of 180 minus theta because they both are same. I can divide one by the other, or in simple language I can cancel both of them. That is one thing which should strike your mind. Ayo, area of triangle is asked, right? Which notation should I use? Should I use equilateral or half into base? You should not think like that, sir. I hope I am making sense for you. That is not the way you need to think. The way actually you need to think is angle in a straight line is 180. This is the theta, means this will be 180 minus theta, so that I will get sine theta and sine of 180 minus theta. If I apply that sine property, sine rule property of area of triangle, they both will get divided because the question is asking for ratio, and when they are divided because they are equal, they will get cancelled. I hope you are understanding. Sir, why should we try to cancel it? Because we don't know the value of theta. Theta value is not given in the question. Suppose if theta value is given as 30 and the other value is also given, something as 60 or 90 or whatever it is, then I know the standard values are sin 30, sin 60, sin 45 or whatever. I can substitute and get the answer. But in this case, I don't even know the theta value. So it is better that we will try to cancel, and this is the way you need to actually think. Now see here, sir. Area of triangle ABC is, it is half into, if I take this angle theta, forget about the opposite side BC, take the other two sides. Other two sides are AB. One of the side is AB and the another side is AC. So it is half into AB into AC into sine theta. This is area of triangle ABC. Ratio with area of triangle ADE. Now angle I am taking is 180 minus theta. So this is half into sine of 180 minus theta will definitely come. I will write it off first itself. Now 180 minus theta opposite side is ED. Forget about that side. Take the other two sides in the triangle. Other two sides are, one is AD, right? One of them is AD and the other side is AE. Let me take these two sides. Now, if I simplify further, this is the beauty of thinking initially and solving. Half will cancel because it is ratio or fraction. Sin theta and sine of 180 minus theta will cancel because they both are absolutely same. From allied angles property, AB value is what we need to find. AB value, what is this? AB. So area of triangle is what we are finding. Sorry, area of triangle ABC divided by area of triangle ADE, right? Area of triangle ADE. This ratio is what we are finding. This is nothing but AB into AC. AB is 6, AC is 4. It is 6 into 4. This AD into AE, bring it to the left hand side. So this becomes denominator. AD value is 6. AE value is also 6. This will ultimately becomes 4 by 6, which is nothing but 2 by 3. The ratio of ABC and ADE, it is not ABE, sir, I made a mistake here. It is ADE. The ratio of ABC and ADE, it is nothing but how much? It is 2:3. I hope the idea is very, very clear for you people, the way I have solved it. The starting approach to the problem is very important, sir. After that, you can easily learn all these things without much difficulty. Starting approach is something which is extremely important. Later, you can take it forward very easily. I hope the idea is clear for you people. Next question, easy question to understand it. There is one understanding between this question and our next question. Let us see what is that understanding. Now see here, in this question we are not finding area. In this question we are finding perimeter is given, side we need to find. But why this question is taken? To help us to solve the next question easily. Now see here, sir, can I say that this question says the three sides of a triangle are in the ratio 4:5:6. There is a triangle The three sides are in the ratio 4 is to 5 is to 6, and their perimeter is 45 centimeter. The sum of three sides is 45 centimeters. Find the sides. Now, how usually our textbook will solve is, let us solve by using textbook method. Method 1. What they will take is, three sides are in the ratio 4 is to 5 is to 6. They will take it as 4x, 5x, 6x, and perimeter according to them. Perimeter according to them is 4x plus 5x plus 6x. 4x plus 5x plus 6x is nothing but perimeter is 15x. Question says it is 45. Equate it. 15x is equal to 45. X is equal to 3. Find the sides. So answer should be 4 into x, 4 into 3, 5 into 3, and 6 into 3. That means we will get the answer very easily in this case also. But what we are mainly worried about here is, let us not use x, y or variables or formulas and waste our time. Let us simplify our problem to the greater extent. Same thing what they have taken it as x. Instead of taking as 4x, 5x and 6x, what I will do is, there is a triangle. The sides are in the ratio 4 is to 5 is to 6. I will assume that this is according to my assumption. I will assume that one of the side is 4 itself, another side is 5 itself, and the another side, third side is 6 centimeter itself. According to my assumption, I can say that perimeter is 4 plus 5 is 9, 9 plus 6 is 15. According to my assumption, it is 15 centimeter. According to the question, it is given as 45 centimeter. Same thing, sir. Here also I did the same thing only, but I am not using x. That's all. Multiplying factor is 3. That multiplying factor is nothing but x value. There is no difference. But why to use that variable? Let us remove that approach, sir. We are fed up of using that variables. But this is anyway a simple problem. You are not finding too much difference between method 1 and method 2. But I have explained you so many varieties of problems in so many topics of time, speed and distance, or profit, loss and discount, or SICI, or whichever topic it is, where using variables is a very time consuming process. Not using variables is a beautiful approach. In fact, in ratios topic itself, I have solved so many questions without using, in fact, 99% of questions without using variables. So multiplying factor, what I got here is 3. So multiply all these three sides also with 3. It is 4 into 3. It is 5 into 3. It is 6 into 3. Answer for this question is 12, 15 and 18. Very easy question. Sir, why this question is related with my next question? Now see here, sir. Perimeter means it is just addition of the given sides. If I add the given sides and then equate it to whatever the perimeter they have given, then it is okay. And if you observe method 1, it is 4x, 5x and 6x. It is x power 1 in all the cases. It is x power 1 in all the cases. So it is 4 plus 5 plus 6, 15. So it is 15x only again, because 15x power 1 only is what you got, because the degree of all these three are 1. When I add them, the degree will still be 1 itself, right? The degree will still be 1. So it is 15x power 1 is what I got. Now let us see our next question, where the degree will change. When will the degree change actually? Instead of adding, if I multiply, the degree will change. That means if I had multiplied it as 4x into 5x into 6x, for example, then the final value would have been, it is 120x cube. It would have been become degree 1 would have become degree 3 in that case. Let us see where that kind of thing will happen, where the degree changes. Now see this question. That was a question on perimeter. Now this is a question on area. Now see here, sir. This is a question on area. And if you see here, this is your original SSC CGL prelims examination question. Yes, it might be 10 years before 2009. But still I am interested in taking some original questions, whether it is recent original questions or little earlier original questions. It really does not matter as long as you are learning few varieties beautifully which can be solved. Now see here, your question is, if the area of a triangle is 117 centimeter square, area of triangle is given as 117 centimeter square, and it is also given in the question as base is to corresponding altitude is 3 is to 4. Base ratio with height, it is given as 3 is to 4. In my method 1, I can take it as 3x is to 4x. Then the altitude of the triangle is how much? What is the height of the triangle is what they are asking you in the question. Find the height of the triangle is what they are asking. Now see here, sir. Just 1 minute, sir. Now see here, they are asking you what is the corresponding altitude or the height. Now see here, sir. If I use my method 1, what is method 1? Method 1 is nothing but I will use variables to solve my question. That is method 1. Always whatever I take usually as method 1 will be the method which you not need to follow. You should not follow actually, right? Now see here, can I say that area of triangle is half into base into height. Basic notation we know it. Area is half into base into height. Area is given as 117, right? It is given in the question as 117. So, and it is, there is a mistake here, sir. It is not 117. It is 1176 centimeter square, right? It is 1176 centimeter square. This is half into base is 3x. Height is 4x. Now, if I simplify further, 2 will cancel with 4. It becomes 2x. So, this is 1176 is equal to 3x into 2x. 3x plus 2x, like my previous question, is 5x. If I add or subtract, the degree of 1 will still remain 1 itself. But if I multiply the degree of 1 when multiplied with another degree of 1, it becomes a degree 2. So 3x into 2x is, it is 3 into 2, 6, and x into x is x square. So x square will be 1176 divided by 6. X square is 196. So what is x value? X value is square root of 196. Square root of 196 is 14. If you remember carefully, I told you this x value is nothing but the multiplying factor what we are finding. Multiplying factor in my method 2 without using variables is nothing but the value of x by using variables in my method 1. That means this x is equal to 14 should actually be my multiplying factor when I teach you method 2 for the same question. Let us not worry about method 2 at the present being, because method 1 is not yet completed here. Height is what they are asking you in the question. Height is 4x and x value is 14. So answer is 4 into 14. 56 centimeters. Answer for this question is 56 centimeters when I solved it by using method 1. Sir, is there any difference between method 1 and method 2? Not too much of difference, but method 2 I will not even use any variables, but I will try to get the answer little faster. And I have taken so many questions in many topics where method 2 will serve as the beautiful way of solving rather than using formulas or variables. What is method 2? Base and corresponding height ratio is given as 3:4. That means according to the ratio, base is 3 centimeters, height is 4 centimeter. According to ratio, base is 3, height is 4. Now, if you observe carefully, they are asking find the height in the question. According to the ratio, height is 4. According to the question, height should be something. That means 4 should be multiplied by something. Or in other language, answer should be a multiple of 4. 42 is not a multiple of 4, ruled out. 52 is a multiple of 4, it may be the correct answer. 54 is not a multiple of 4, ruled out. 56 is a multiple of 4, this also may be the correct answer. Now, there are two options, either 52 should be correct answer or 56 should be correct answer. You take any value whatever you like. Suppose if I take 52 for example, I am assuming that second option 52 is my right answer. This is my assumption. 4 into which number is 52? 4 into 13 is 52. 3 also multiplied by 13. Sorry, 3 also multiplied by 13. 13 into 3 is how much? 39. That means base is 39, height is 52. Area of the triangle is half into base is 39, height is 52. So this is 2 into 1, 2 into 26. But think little logically, sir. Actually, your area should be, according to my second assumption, if I assume the area as 52, sorry, if I assume the height as 52 centimeters, I am getting the area as 39 into 26. But question says area is 1176 centimeters square. Check whether they both are equal. Sir, should I multiply 39 and 26 and find out? No, if you are multiplying, you did not learn A and C shortcuts. As simple as that. Don't multiply. Here the unit digit is 6, which is given in the question. 9 into 6 is 54. 39 into 26, unit digit is 4. Unit digit 4 and unit digit 6. Are they equal any time? No, definitely they cannot be equal. Therefore, my assumption of second option of 52 is incorrect. Out of 4 options, already option A was eliminated. Option B I eliminated just now. Option C was eliminated because it was not a multiple of 4. Therefore, the correct option is option D, which is 56 centimeters, and that is exactly what I got by using method 1. If you observe method 2, I don't even use any variables here, and I can solve it so easily and the most beautiful way possible. If you are little lucky, sir, take my words, I am just telling because I have seen so many questions of this sort also. If you are little lucky, base height according to the ratio is 4. According to the question, they are asking you how much. Multiply 4 by something, or in other words, answer should be a multiple of 4. If you are lucky, out of 4 given options, if there is only one option which is a multiple of 4, then you don't even have to check all these things. You can directly mark that particular option and you can move forward, provided we are solving in a worst case scenario of 95-96% taking chances that multiplying factor will always be a whole number. There is no rule that multiplying factor is a whole number, but in majority of the cases, multiplying factor will be a whole number. If you really have time, find the values sitting and solving each and every step. If you are in a little hurry so that you need to solve so many other questions, use this kind of smarter approach. Yes, beautiful, sir. Can I move on to method 3? Is there any other thing which I can think about? Why not? Definitely. This is what the flexibility A and C gives you of thinking in multiple methods. Keep thinking in different methodologies. This method 3 is quite similar to method 1, but without using any variables. Base is to height. It is given in the question as 3:4. Now, according to ratio, base is 3 centimeter, height is 4 centimeters. Can I say that area of triangle is half into base into height, right? It is half into base into height. So this is given in the question as 1176. So base into height, it is 1176 multiplied with 2. This is nothing but 2352. But think a little logically, sir. Can I say that according to ratio, base is 3. According to ratio, height is 4. According to ratio, base into height is 3 into 4, 12. According to ratio, it is 12. According to the question, it is 2352. 12 should become 2352. multiplying factor is 196. But hold on, sir, you told multiplying factor is x value, but it is x square value. Yes, this is where you should be little careful compared to finding the perimeter. In perimeter, the degree will not change. 3x plus 4x will become 7x, where the power or the degree is 1 itself. But 3x into 4x will become 12x square. That means basically this is 12x square is 2352. So x square will be, so x square is multiplying factor is 196. X value is 14. Or in simple language, instead of thinking all those things like that, simple way of understanding is, if it is a perimeter based question, whatever the multiplying factor you get here, that is the x value, because the degree will not change. If it is a area question, whatever the multiplying factor you get here, that should be equated with x square, and then take the square root of this multiplying factor to get the original multiplying factor. So original multiplying factor is not 196, it is square root of 196 14. Suppose if it is x cube in our volume based questions, in our 3D mensuration, which we will see later, then you should take the cube root of that multiplying factor what you have got. I hope you are understanding the difference. That means the actual multiplying factor is 14. Multiply this 4 also with 14. Answer is 14 into 4, which is 56. I hope you are understanding, sir. In simple language, 12 is becoming 2352. Normally, how you find the multiplying factor? Find the same multiplying factor. 2352 divided by 12 is 196. Use the same approach how you used to find the multiplying factors earlier. But what you need to do is, this is a question on area. Because it is area is always square units or units square. Take the square root to get the actual multiplying factor. Suppose if this question is volume is unit cube. Take the cube root of that multiplying factor what you got to get the original multiplying factor. I hope you are understanding the difference. Sir, I am more comfortable with method 2. Yes, please go ahead. Your wish. It's completely up to you. Sir, I am comfortable with method 3, sir. Please follow. Sir, I am more interested in method 1. But I think that method 1 is a very lengthy method. As you proceed with more and more questions, try to avoid using method 1, sir. My sincere request, because A and C is not habituated to that kind of methodology where we use variable to solve the questions. And I believe that you have seen so many videos of I taking classes without using variables, Anil sir taking classes without using variables, and making a very difficult problem look in the most easiest way possible. Let us try to use that kind of methodology which will simplify our problem rather than making it complicated, because our life is already complicated. I hope the idea is clear for you people. Next question, see here. This is your original SSC, CGL and prelims questions. 2002 it is, but still I want to take some good examination questions. Although this is a very easy questions, I am starting with level 0 and level 1. Let me scale up the level of difficulty after some time. Your question is, the base of a triangle is 15 centimeter and height is 12 centimeters. Okay, base is 15 centimeters, height is given in the question as 12 centimeter. Beautiful. The height of another triangle of double the area having the base 20 centimeter is how much? Now what they are saying is, whatever the area which I am getting in my first triangle, in my second triangle area is the double, right? Height of another triangle, this is my another triangle, second triangle, height is how much they are asking. Having double the area compared to the first triangle and also having base as 20 centimeters. Find the height is the question. Very easy, right sir? Half into base into height is the area of the first triangle. So it is 2 times of 6. 15 times of 6 is 90 centimeters. Area of the first triangle is 90. And area of the second triangle, let me call first triangle as A1, second triangle as A2. A2 is nothing but 2 times of A1. So it is 2 times of 90. which is 180. That means so area is 180 is equal to half into base is 20, height is I don't know, 2 times of 10 is 20, 10 into 18 is 180, height value is 18 centimeter, which is nothing but my option B. Very easy question, sir. Next question. Now, before moving on to the next question, in our geometry class, I am damn sure that you would have learned this Pythagorean triplets. If one of the side is an odd number, how to derive the Pythagorean triplet. If one of the side is an even number, how to derive the Pythagorean triplets. We have discussed in detail in our geometry class. Anil sir has taken that in detail. I also have taken it in detail in my trigonometry class also. So let me not go deep into the topic once again, but basic Pythagorean triplet is 3, 4, 5. You already know it. 5, 12, 13. You already know it. Like that there are basic. And you can derive infinite number of Pythagorean triplet. If you know the logic, what we have taught you, how to derive Pythagorean triplet. If one of the side is an odd number, or the second case is one of the side is an even number. Now, 3, 4, 5 is a Pythagorean triplet. If I multiply this by 3, it becomes 9. 3 into 3, 4 into 3, 5 into 3, 9, 12, 15 is also a derived Pythagorean triplet. If I multiply this by 4, 4 into 3, 12, 4 into 4, 16, 4 into 5, 20, 12, 16 and 20 is also a Pythagorean triplet, which is derived from my basic Pythagorean triplet of 3, 4, 5. Sir, why are you discussing this? Why are we taking this 12, 16 and 20? Because that is our next question. Beauty of knowing the Pythagorean triplets. See here, sir. Original SSC question which was asked in 2013. The sides of a triangle are 16 centimeter, 12 centimeter and 20 centimeter. So sides are 12, 16 and 20. 12, 16 and 20 form Pythagorean triplets, and Pythagorean triplets is applicable only for a right angled triangle, right? That means what you should definitely identify here is only for a right angle triangle Pythagorean triplets is applicable, and this is what is given in the question. Therefore the values which are given are nothing but for the values of a right angled triangle. That means hypotenuse is always the longest side 20 and the other two sides are 12 and 16. It can be interchanged. Area of right angled triangle is half into base into height. Base is nothing but 16, height is nothing but 12 divided by 2. 2 into 1, 2 into 8, 8 into 12 is 96 square centimeters. Answer for this question is option C. The one thing which is very important in this particular problem is you people realizing the fact that 12, 16 and 20 is nothing but a Pythagorean triplet. If you don't realize it, probably you might not be able to solve it a little easily. That is what I can say it from this particular problem. And once you identify it, the problem is very easy to solve. Next question. Next question. See this question, sir. Your question says the area of the largest triangle that can be inscribed in a semicircle of radius r centimeter is how much? Again a original SSC SI question in 2004. Diagram is already there on the right side of the screen, but let me write the diagram one more time for you people so that it will be very clearly visible. Please do not worry, sir. I am writing the diagram. Diagram might not be drawn to the scale. Kindly correlate with me. So this is a semicircle, right? This is a semicircle. What they are saying is there is one line like this. and there is another line like this which is touching the circumference of the circle, another like this, and the radius of the semicircle is given as r. These two are r and r. I hope till here it is clear. This is what the diagram which is given in the question. Now what is that they are asking you is the area of the largest triangle. Now see here, sir, can I say that the triangle can also be drawn till here only, like this only, that blue color whatever I have drawn right now, that can also be one triangle. This can also be another triangle. Like that there can be so many triangles which can be inscribed inside a semicircle, but they are asking you the area of the largest triangle. When will the area is maximum? When will the area become maximum? Area is maximum only when this triangle is having the maximum base. Sir, in all these cases, there are three triangles which you have drawn right now inside the semicircle. In all these cases, the area is the same. Sorry, what is the area? Not the area, sir. What is that? Base is the same. In all these triangles, the base is the same. But if you see, height of this smaller triangle is only this much, and the height of this second triangle is from here to here. It is the height of the second triangle, and the height of the biggest triangle, largest triangle, is toward the circumference of the semicircle. It is touching. That means area is maximum. Area of triangle is maximum. When it is maximum, sir, area of triangle is maximum only when base should be maximum, and height also should be maximum. Only when base and height are maximum, that is the case, the area of triangle also will become maximum. I can also draw a triangle starting from here and ending here like this also, right? The height is this much and the base is put on a smaller one here, right? It's a very smaller base here. So base should be maximum. That means the base should be basically the diameter of the of the semicircle, and the height should be something which is touching the circumference from the diameter. That is when the area of the triangle becomes maximum. That means maximum base is nothing but diameter of the semicircle, which is r plus r, which is 2r. Similarly, maximum height, when will it become the maximum height? Can I say that from this point, let me use a different color, let me use suppose for example, which color, sir? Green color for example. From this point till this point, this also is the radius of the semicircle, right? That also is the radius. Maximum height is radius. That means area of the triangle which is inscribed in a semicircle of radius r centimeter is half into maximum base is 2r, maximum height is r. 2 cancels. Area of this semicircle, area of the triangle is, area of the largest triangle is r square centimeter square, which is nothing but my second option. I hope the idea is very clear for you people, sir. See this next question. Again, your original SSC CGL prelims questions in 2007. The area of the shaded region in the given below figure is how much? In the given below figure, what is the area of the shaded region? This is the figure what they have given on the right side of the screen. Let me draw it one more time for our better understanding. Now see here, sir. This is the circle, and they have split that circle into 4 equal parts. Diagram is not drawn to the scale. Probably let me remove this line and draw it in the middle so that at least it looks little good. Okay. This is little better diagram. Now they are inscribing a triangle inside, right? They are inscribing this triangle inside, and when they are inscribing the triangle, this particular area is what they are actually interested in asking you. This shaded area is what they are actually asking you people. Now see here, sir, very simple. Forget about this lower part of the triangle. I can remove that also, right? Forget about not the triangle, in fact, forget about that lower part of the circle. Why should I forget? Because the shaded area is not there at all in that lower part. Shaded region is only present in the upper part of the circle. So I will only consider the semicircle, right? I will only consider the semicircle. How will I get the area? Can I say that? Listen, observe carefully. This is my semicircle. This is my semicircle. From this entire semicircle, I will remove off this triangle area. I will remove off this triangle area from that entire semicircle. If I cut this triangle, I will be left only with that shaded portion. That is what they are asking you people. That means area of the shaded portion is area of semicircle. Area of semicircle, you need to first find it. First find the area of semicircle. From that semicircle area, remove that area of triangle. If I remove the triangle from that semicircle, I will be left with area of the shaded portion. Removing is nothing but subtraction. Now, first of all, if I name the radius of the semicircle as A units. Sir, why are you taking A? Why not R? In the answer options also, answer is given in terms of A itself. So radius, I will definitely take it as A itself, because answer option says A. If the answer options had said R, I would have taken R, as simple. So area of semicircle. First of all, what is the area of circle? Area of circle is pi A square, but it is semicircle. So it is half into pi a square. You should remove what? You should remove the area of a triangle. If this is the radius of semicircle, then I can also say that this also is the radius of semicircle. This is the radius of semicircle, and this also is the radius of semicircle. So area of triangle is half into base. Base is nothing but a plus a 2a. Height is nothing but this A, right? This particular A, perpendicular one, right? Now that means this half, if I take common factor, A square also if I take common factor, half A square if I take it outside, here I will be left with pi, minus here I will be left with 2. Or in other language, I can also say this as multiply this half inside the bracket, this becomes A square into pi by 2 minus 2 by 2. Final answer is A square into pi by 2 minus 1 square units, which is nothing but option C. Very, very easy question, sir. But you should know that idea, or you should understand how you should actually represent the diagram, how you should actually visualize the diagram. From the entire semicircle, if I cut it, take a knife or a scissor or whatever it is and cut it. Remove the triangle. You are only left with that shaded portion, right? That is what it asked in the question. So that is nothing but subtraction. I hope the idea is clear for you people. Next question. Again, a original SSC question in 2013. If area of an equilateral triangle is small a, area of an equilateral triangle, that means all the three sides are same, right? All the three sides are same. Area of that equilateral triangle is given as a small letter a, and height is small letter b. Height of that equilateral triangle, it is given as b. Find the value of b square by a. B square, that means height square divided by area value we need to find. A value is nothing but area only, right? Height square divided by area value we need to find. Now see here, sir. First of all, it's an equilateral triangle. What is the general notation for an equilateral triangle area? Area of an equilateral triangle is, it is root 3 by 4. into side square. I don't know what is the value of side, so I will keep it as side itself. Area of equilateral triangle is root 3 by 4 into side square. But in the question it is given as A, right? A small letter A is the area. Now height. What is the height of an equilateral triangle? That also we have seen it in the starting basic understanding of triangles, quadrilaterals, all those things. There itself we have found out height of an equilateral triangle is nothing but root 3 by 2 into side. But height of an equilateral triangle in the question it is given as a small letter B. Right? Now I need height square. That means this particular value I should square it, or in other words I should square this B value. So B square is equal to root 3 by 2 square is nothing but 3 by 4. This side square, if I do it, it will become side square, and this B square value I should divide it by A value, right? So divide this B square value by A. A value is nothing but root 3 by 4 into side square. That means I don't know side value, anyway it will cancel off, no issues. 4 will cancel with 4. You are left with 3 divided by root 3. 3 divided by root 3. 3 can be written as root 3 into root 3 divided by root 3. So root 3 cancels. You are left with 1 root 3. Answer is option C. Next question. See this question, sir. Beautiful question. SSC CGL Tier 1 question 2013. See this question, sir. Let us solve two questions of similar type. This question and the next question for our better understanding. Your question says C1 and C2 are two concentric circles with center O. Let me write the diagram once again for your better understanding. There is a center O. There are two circles. This is circle 1 and there is another circle with center C2. That will be the outside circle with the same center O. Diagram is not drawn to the scale. Let me remove that outside circle and draw it once again little neatly, sir. Okay. Now see here. C1 and C2 are two concentric circles with center O. That is one thing. Their radii are 12 centimeter and 3 centimeters. That means this entire bigger circle radius is 12 centimeters. The smaller circle radius, that means this particular portion, or I can also call this as my radius, right? This is given in the question as 3 centimeters, right? This is given in the question as 3 centimeters. Let me give this point as point A and this point as point B. Now, what are the things which are given? B and C are point of contact of two tangents drawn to C2 from a point A lying on circle C1. That means point A is lying on circle C1. I will draw the tangent and that tangent will touch circle C2 at point B, which I already named. Another tangent will touch circle C2 at point C, which I am naming right now. I hope this point is clear. Then the area of quadrilateral ABOC. This particular quadrilateral value I require. Area of quadrilateral value ABOC. This value is what I require. That is what is exactly written in my right side of the screen. The diagram is already given in the screen, which I wrote it once again for our better understanding. Now let us find the area of quadrilateral. Now see here, sir. Think little logically, you will get the answer very easily and very beautifully. Now, what is this? I am damn sure that you know this property. Suppose, for example, if I take this triangle, which triangle it is? AOB. If I take the triangle AOB, let me write the triangle here. It is AOB. AO value is nothing but 12 centimeter radius of bigger circle. OB value is radius of smaller circle, which is 3 centimeter. But one thing which I am damn sure that you should know this property is angle in a circle is 90 degree. Angle subtended at the circumference of a circle. There is another circle which I have marked it in red color. That is a smaller circle. And this particular point B is on the circumference. Angle subtended is 90 degrees. That means this angle B is nothing but 90 degrees. This is very, very important, sir. Angle B is nothing but 90 degrees. If this is 90 degrees, this becomes a right angle triangle. Opposite to 90 will become hypotenuse. AO is hypotenuse. AO square is equal to OB square. OB square plus AB square. But what is that AB? Opposite to 90 is hypotenuse. OB is nothing but the height of this triangle. AB is nothing but the base of that right angle triangle. That means AO square is 144, OB square is 9. So AB square is what I need to find. So AB square is nothing but square root of 130. AB square is 144 minus 9, 135. So AB is square root of 135, which is 15 into 9. Square root of 9 is 3. So AB value is nothing but 3 root 3. AB value is nothing but 3 root 3. That means this particular value is 3 root 3, which is known to us. Sir, why are you taking like that? Why are you doing that way? This AB is 3 root 3. And we know that it is a right angle triangle. What is the area of a right angle triangle? Area of right angle triangle is half into base into height. So in this case, it is half into base is nothing but how much? Base is nothing but 3 root 3. I hope you are understanding. If base is nothing but 3 root 3. Sorry, it's not 3 root 3, sir. It is 3 root 15 here, right? So I made a mistake in each and every case. So it is 3 root 15, right? Here also it is 3 root 15. Base is nothing but 3 root 15. Inside here also it is 3 root 15. So base is nothing but 3 root 15. Height is how much? Height is nothing but OB. OB is nothing but 3. That means, can I say area of AOB is nothing but, this is nothing but 3 into 3, 9. It is nothing but 9 root 15 by 2. Sir, but the question is not asking for the area of triangle AOB. It is asking for the area of quadrilateral ABOC. This is where you need to know the property of a quadrilateral. If this triangle is ABO, where B is 90 degree, because point B is on the circumference of the circle. Similarly, point C is also on the circumference of the circle. And if point C is also on the circumference of the circle, angle subtended at angle C, angle subtended at point C is also 90 degree. That means whatever the area you got it for AOB, the same area will be for AOC also. That means area of triangle AOB is absolutely same as area of triangle AOC because of similarity triangles. So if AOB area is 9 root 15 by 2, AOC area is also 9 root 15 by 2. But the question they are asking you to find the total area of both these triangles so that it becomes a quadrilateral ABOC. So it is 9 root 15 by 2 for AOC plus 9 root 15 by 2 for AOB. So it is x by 2 plus x by 2, which is nothing but x. So answer for this question finally is 9 root 15 square centimeter, which is option C. There is a beautiful understanding which is required to solve all these questions, sir. And that is the reason I am explaining you very slow in detail. Please practice these varieties in the way it has to be practiced for your better solving in your examination hall. Sir, one question is beautiful, sir. I understood it. Can I have one more question for practice? Definitely, we will solve a similar kind of questions, which is my next question, where we will also understand how to solve that question in the same method what we have solved here. Please see my question number 12. Diagram is already there on the right side. Let us not waste our time in drawing the diagram once again. Let us understand it then and there itself. From a point P, there is a point P which is at a distance of 13 centimeter from center O. Center is O. 13 centimeter the distance is. Instead of drawing two circles, they are just showing it by one circle itself. That is the only difference. It really does not make any difference between the previous question and this question. So of circle of radius 5 centimeter, from O to P it is 13, but O to this point which is the radius, it is 5, only 5. Or in other words, OQ is also 5, because that is also the radius of the circle, right? OQ is also 5. In the same plane, a pair of tangents PQ and PR are drawn to the circle. From P I will draw a tangent to Q, PQ. From P I will draw a tangent to R, it is PR. In the same plane it is drawn. Find the area of quadrilateral PQOR. This quadrilateral which I am drawing in red color, PQOR. This quadrilateral area is what I am interested in finding in this question. This is exactly similar to my previous question, sir. Can I say that if I take this upper triangle, let me draw it with a different color for your better understanding. If I take this upper triangle POQ, upper triangle POQ is something like this. This is POQ and this is 5, this is 13, and definitely this is 90 degree. Although it is mentioned already here, you should understand that angle in a semicircle or angle at the circumference of the circle, angle at the circle circumference is 90 degrees. So this is 90 degrees and it becomes a right angle triangle. 5, 12, 13 forms a Pythagorean triplet. So other side PQ should be 12 units. You don't even have to apply Pythagoras theorem also. Now this is 12. Area is half into, what is the base of this right angle triangle? It is OQ, right? Base is nothing but OQ, which is 5. And height of that, okay, that is height anyway. Height of that right angular triangle is 5. Base is nothing but PQ 12. So this is 2 into 6. 6 into 5 is 30. And if this POQ is 30, here also angle R is 90. So this POR also will be 30. So final answer is 30 plus 30. Exactly similar to my previous question. Answer is 60 square centimeter, which is nothing but my option B. If you observe carefully, sir, question 11 is an original SSC question, Tier 1 SSC CGL 2013. Question 12 is also an original SSC question. If you again observe, both are of same dates also. That means in a question, there are two things which are two questions of similar model are given in an examination paper, is what you can understand from this. I hope the idea is very clear. Maybe a different sitting, but exactly similar questions were asked in the examination in 2013. That does not mean that you should not study in the year 2019. Equally important for you to know all these things before you solve any questions which is coming forward. I hope the idea for these two questions is very clear for you people. Please see question number 13 and see the beauty of this question. SSC CGL Tier 2, 20th February 2018. This is a last year question. That is the reason I am telling you, don't ignore the questions which had come 5-6 years before, because this question is also more or less similar to that questions what we have solved previously, two questions. Now see here, sir, let us understand the question. Diagram is already given on the right side, but let us still understand the question. Now see here, triangle PQR is inscribed in the circle whose radius is 14 centimeter. There is a triangle PQR. This is inscribed in a circle whose radius is 14. If the radius of the circle is 14, the diameter should be 2 times of radius, which is 28. Okay. If PQ is the diameter, now only you can make this PQ as 28, right? If PQ is the diameter of the circle and PR is 10, the value of PR is also given as 10. What is the area of triangle PQR? This triangle area is what they are asking you in the question, right? Area of this triangle is what they are asking you. Now see here, very easy, sir. First thing what you should understand, whether it is given or not given, is angle formed at the circumference of the circle. Angle at the semicircle is 90 degrees. angle R is 90 degrees. I hope this part should be very clear for you. If that is 90 degrees, first thing is, what is the area of this triangle? It is half into base is nothing but, so opposite to 90, it is hypotenuse, right? Opposite to 90, 28 is hypotenuse, but other two sides are base and height. Height is QR. I don't know the height QR, which I need to find it. Let me find it in some time. And base is PR. PR is 10. So it is 2 into 1, 2 into 5. That means area of triangle is 5 times of QR. If I find out that QR value, my answer is absolutely completed. But how to find QR? Very easy, right? It's a right angle triangle, right, sir? Apply Pythagorean triplet. Hypotenuse square. PQ square is equal to PR square plus QR square. PQ is 28. 28 square is 684, right? Sorry, yes, 28 square is nothing but 684, because how much, sir? 28 square, it is 625, not 684, sir. 28 square is 784, right? 28 square, okay, we will not even use that. 28 square, RP value, is it known? Yes, it is 10, so it is minus 10 square is equal to QR square. So 28 square is 784 minus 100, it is 684 is equal to QR square. So QR will be square root of 684. So 684 can also be written as 36 into 19, because 36 into 20 is 720. Subtract 36 from 720, it becomes 684. Square root of 36 is 6. So QR value is 6 root 19. But I don't want QR, I want area. So area is 5 times of QR. 5 times of 6 root 19. 5 into 6 is 30. 30 root 19 should be your answer for this question. I hope the questions are easy, sir. And please see the nature. It is an original SSC CGL Tier 2 questions of 2018. So please do not underestimate all these questions. Please consider yourself lucky if you are getting this kind of questions in your examination hall.
Press the bell icon on the YouTube app and never miss another update.